Okay, so this is the continuous video of my last video about longest palindromic substring. So in my last video, I solved this question with 2 pointers. So here, in this video, I will solve this question with dynamic programming. So firstly with top-down DP and then bottom-up DP. So when I think of this question, I have to think of 2 cases, basically. Yep. So this is number 1 and this is number 2. So here, this is a palindromic substring, and here, this is a palindromic substring. The difference is that in the first case, the center character is exactly the C, but in the second case here, the center character is between 2 characters. So that's a basic difference. And anyway, I will use the top-down DP. So what I'm interested in is if this, I will think some, range, and would like to know this is a palindrome or not. So in that case, basically I can say I have to check if X character is equal to Y and S is palindrome. I can say this. If 2 characters, the leftmost character and rightmost character are the same, and also the inner string is palindrome, then I can say S1 is palindrome. So basically, I will use this logic in the recursive function. So the recursive functions looks like this. Yeah. So I will check if the specific range from index low to high is palindrome or not. And I can use recursion to answer this question. Yeah. So that's what I will do. And obviously, I can solve this question recursively. And also, once I check if the specific range is palindrome or not, I can use that result again and again. I don't have to calculate that again and again. It's a redundant work. So I will do the memorization with cache. So I can say I can use the top-down dynamic programming here. And the base case should be, if the given string is single char or 2 chars. In that case, I will take it as the base case. So basically, if there is only one character, it's a palindrome. Yeah. I can say it corresponds to this case, character C. And if there are 2 characters, in that case, low and high characters corresponds to this B and B. So I will check if they're the same, and if true, I will return true. If not, I will return false. So I will take it also the base case. Okay, so that being said, one thing I have to take care is I have to check every string, every substring is palindrome or not. Or I should say, yeah. I will quickly write it. Here, I will call this. I'm almost writing the copy code. But here, I will update max palindromic substring. Yeah. And I will return it in the end. So this is the basic idea I will do. So yeah, it's not enough. I just check low and high. I mean, index 0 to n minus 1 only, because it cannot be palindrome, but it may be other, say, index 0 to 3, or maybe n minus 2. It can be the palindrome. So I have to do the for loop and check every substring if it is palindrome or not. Yeah. So I can say the time complexity here is n squared. So this for loop has n squared steps. And basically, when I take a look at this is palindrome recursive function, it takes only the constant time aside from another recursive function call. And the number of the calls of this recursive function should be n squared because it checks low and high combination, which can be n squared. Yeah. So I mean, I'm out of n characters, I'm trying to get low high combination, which should be n squared pairs. And for each, it takes constant time to do the recursive function calculation aside from another recursive function. So it should be n squared times 1 is n squared. Unfortunately, fortunately, I don't have to do n squared times n squared. Because I can think there are n squared outer loop and inner loop. So it should be n squared times of this call. And I can separate the time complexity which takes for this is palindrome method. Yeah. Even though I take n squared times call of this is palindrome method, let's assume it takes only the constant time. And I thought, what time does it take to calculate every possible is palindrome function call in the as a separate calculation. In this way, it should be n squared. For space complexity, I need the cache and also recursion stack. For cache, the key should be low high combination, which should be n squared. The value should be the Boolean, so it takes them with the constant space. So in total, it should be n squared. And for recursive function, when I start with low high 0 to n minus 1, and let's assume I'm losing 2 characters from left hand side and the right edge. I mean, I will be losing, where I should say removing left character, rightmost character, and rightmost character in every recursive function step. So it runs out of the whole n characters in n divided by 2 recursion depths. So the recursion stack should be n divided by 2. The base complexity in the worst case. If I start from low high is 0 to n minus 1. So it should be n squared space complexity. Okay, now I will start the implementation. So um, one thing which I tweaked is this part, longest row and longest high. So when I find the longest string, instead of initiating the longest palindromic candidate substring, I just keep track of the index of that low and high pair. Yeah. So this is because if if I initiate the string here in line 51, what happens is that it takes another overrun time here. Because in Python, if I try to create take the slice of the index in the string, it actually initiates a new string. So it takes at first O of n time. And as a result, it takes O of n cubed time complexity. I didn't do that. I just kept track of the um, longest strings low and high index pair and initiates the longest string in the end only. So in line 53, this part only takes O of n time out of the for loops. So it doesn't affect the time complexity. Okay, so now I will implement the helper method. Okay, and I just want to check this one here. Okay, so if there is only single string remaining, it's the base case and the return true. If there are two characters only, if they're the same, return true. If not, I return false. And aside from the base case here, I will check first leftmost character is equal to rightmost character. And if it is the same, and also if the inner string is also the palindrome, I can say the given string is palindrome. Okay, so I quickly do the dry run. So let's say very simple case like AA. So with this, so n is now 2. So for here, this should start with 0, 1. And if it is 0, I have 0, 1. But from 1, it should be only 1. Anyway, I will check this case first. 0, 0 case. I will check if this is palindrome or not. I go here and this is met. And then line 63, low is equal to high, so I return true. So yes, this is true. And current ranks is now 0 minus 0 plus 1 is 1. Longest rank is 0 minus 0 plus 1 is 1. So there's the same. So I don't go into this for if statement. And I come back to line 50. And now index is 1. In this case, I call is palindrome with 0, 1. And in line 65, this is true. So I return S row is equal to S high, which is true because both of them are AA, true. So, hmm? Yeah, so I return true. So now in line 51, this is true. So I go to line 52, and now what I get is 1 minus 0 plus 1 is 2, which is largest and longest ranks here. So longest low, longest high is updated with 0, 1. Yep. and I come back to line 52, and for loop is ended, so I come back to line 51. So when I start with index 1, high should be only 1, only. Yeah. So what happens is, this is a palindrome, yes, because row is equal to high. So in line 56, this returns true. So now I go to line 54, and current range is, 1 minus 1 plus 1 is 1. So this isn't longer than the longest range here, because it's now 0, 1. Sorry, here. Plus 1 is 2. So I go out of the for loop, and I go to line 59, and I return string 0 to 2, which is AA. Yep. So I passed this test case. Okay. The only line I haven't covered is line 70. I don't do dry run any one more time, but I'm pretty sure on this. Let me quickly check only this method with S is ABA, and low is 0, high is 2. So the whole string, I check if the whole string is palindrome or not. So here, I go to line 75, skipping 71 or 73. Yeah, because low plus 1 is 1, which is smaller than high. Yeah, so in line 75, S row is equal to S high. This is true. Both of them are A. So I check, code this one. The firstly, I call this, and secondly, I call this. Yeah, and I'm pretty sure this returns true because this is covered in line 74 in the recursive function call. So this returns true. So I can say this is true. So its palindrome is now true. Yeah, so exactly this is as expected. So I checked on with the inner function, helper function is palindrome, and I could confirm that it works fine with covering line 78. Okay, so I'm pretty confident in my code, so I submit. Good. The memory limit exceeded. Okay, yeah, let's go for it. I mean, I actually solved this question so many times, and actually, O(n) squared space with top-down recursive function, or top-down dynamic programming, always ended up with memory limit exceeded. So far, I couldn't find any way to work around this problem. But it's okay. At least I could find out and implement top-down DP approach. So let's go with bottom-up DP. So this one is a bit complex to implement compared with top-down DP. I think top-down DP is the best approach. Sorry, actually, two pointers is the best approach because it takes a constant space. But just for my practice, I did top-down and bottom-up. Yeah, and I'm pretty sure top-down is easier if I compare with bottom-up. But say I will do this just for practice. Okay. So let's say my task is to check the longest, find the longest palindrome string in this string. So I'm expected to return ABC actually. And here, when I do the bottom-up DP, I will think of it in this way. I will think every string which start from sorry. Let me put this start here. Start char is X A B C Y Z. And for end char, it should be like this. A bit hard to understand maybe, but I will assume start char starts from X here and ends with this char. So when I take a look at each cell, for example here, this suggests represent substring X. And here, this suggests represent XA. For example here, represent Z because the substring starts from Z and ends with Z. And that being said, I cannot start from, for example, A and ends with X. So here, I should completely forget. This is an invalid and non-existing substring. Okay. So, first thing when I take a look at this substring, this is a single character substring, X. So this is actually the base case I considered in the top-down DP. I can immediately say, yes, this is palindrome. Yeah. Because it has only a single character. So I will fill in Boolean if the substring is palindrome or not in this table, 2DDB table. Yeah. And here, it has only two characters, XA. So I can know this is palindrome or not just by checking if X and A are the same or not. Not true, not true, not true, not true for them. Yeah. Okay. And so from here, when I take a look at this, let's think if this XAB is equal to palindrome or not. Yeah. I can say if, this is palindrome if character X is equal to character Y. So start char is equal to end char. And if this is palindrome, string 2 is also palindrome. Almost the same logic I saw in the top-down DP. Yeah. So what I should do here is, firstly, I will check X is equal to B. And if it is not true, I can just fill in false. Same for here, same for here, same for here. Okay. And here, wait a minute, is this okay? No. A, B, C, X, sorry. Let's change this to A, B, A. So if I change this, I can say here, this n start with A and end with A. So this part becomes true. So I will check this. And string 2 is actually B only because I remove A and A from A and A from ABA. So what's the position of the cell which represents this B, which is this one. So, which means that I can check in this way. So when I would like to know this cell, string 2 result is here. And I'd like to know this result. So I can always say, if I remove 2 start character and end character, the remaining string is represented in this position, bottom left cell. So in this case, it's true. I can say this is true and true. So it now fills in with true. Yeah. So I continue this. Basically, this is false. And this is false A and Y. This is false B to Z. This is X to Y. This is A to Z. This is X to Z. Yeah. Okay. And after filling in this cell, this table, I will get the longest substring. So I think I've done the similar logic in the top-down DP, but again, in the iteration to fill in these cells, I keep track of the longest mini and longest max indexes. Yeah. And finally, I will return this one. Okay. So that's what I will do in the bottom-up, bottom-up DB approach. And one thing I'd like to take care is that the order of cells to be filled in. Because I always would like to know this result to fill in this result. So how can I should say this one should be filled in first and this one should be filled next. And I can say this relation for all the cells. That being said, the cells should be filled in this order. Yeah. So if I fill in this diagonal, in this way, I can always find bottom left cell to be filled in already. So I can always fill in the cell based on the previous result. Okay, that being said, I will do the complexity analysis. For time complexity, this should be O of n squared because I have to fill in n times n divided by 2 cells. And for each, it takes only the constant time. Because what I would do is check line cells is 6. And for space complexity, it will take n squared because I need a dp table, which is 2D. And only that. Okay, that being said, I start my implementation. So as I said, I start with this cell. So this one, row is 0 and column is 0. Yeah. So what should I do? So in this way, now I can choose the first, cell for each number. And what I will do from here is I will move it to bottom right direction. So internally, I have to move row and column in this way. But what I have to take care is if I do this, this row and column is updated and then updated in line 64 and come back. This is not what I intend. So let's call init row, init column. And here, I assign row and column in this way. This is better. So in this way, init row and init column keeps moving this first row. Init row is always 0 actually. And for R and C, it moves diagonally. So this is updated while going the inner while loop, but it doesn't affect the init row, init column. That's okay. Okay. So here, what I would do is fill in the cell. So yep. Row +1, column -1. Okay. So now I've filled in the DP cell. And as I said, I have to keep track of this. Let's start with 0, 0, because it guarantees that S has at least one character. And also, if I take the single character as the substring, it always a palindrome. So 0, 0 is actually palindrome. Here, if this is true, so And if current length is longer, then I update the longest mini, longest max with row and column. So let me just rename the mini to low and max high. Okay. And in the end, I return the substring, which is the longest. Okay, I think this works. So let me quickly check. Especially, my concern is about the row column movement. So I will check with ABA case. So if this is the 1, and it's 3, and longest row, longest high begins with 0, 0. Yeah. So DP is initiated with always none. Okay. And firstly, init row, init column begins with 0, 0. Okay. And now in line 68, init column 0 is less than 2. Yes. The row column begins with init row, init column, which is 0, 0. And 0 and 0, both of them are less than 2. I go to line 72. And because row is equal to column, db row column is now true. Yep. And then go to line 79. And because this is true, I check current ranks, which is 0 minus 0 plus 1 is 1. Longest rank is now 0 minus 0 plus 1 is 1. There's the same, so no update on longest row, longest high indexes. So I go to line 85, and row and column is incremented by 1. So I go to this cell. Exactly as expected. Move software. And I go to line 71. And yeah, I quickly skip because I'm pretty sure this is less than 2. Both of them are less than or equal to 2. And row is equal to column. Yeah. Indexes is the same. 1 and 1. So I fill in true. And I go to line 79 and 80. And here, this current rank is 1 minus 1 plus 1 is 1 again. So this doesn't exist. Longest rank is 1. So I come back to line 71. Oh, no. I go to out of the if statement and go to line 85. And I increment row and column. So it goes to 2, 2. And again, I'm pretty sure what happens is that row is equal to column. So I fill in 2 here. And I go to line 79 and 80, but current rank is 1, which doesn't exist 1. So I go to line 85, and row column goes to 3, 3, and come back to line 71. But now 3 is not less than or equal to 2. So I go out of this while loop. And then what happens is init column plus equal 1. So this move to 0, 1, which is here. Okay. So I'm pretty sure the move, the transition of init row, init column, row column are correct. Yeah. So this part is good. Actually, I haven't covered is line 75, line 77, line 83, line 90. So I try to focus on that. So aside from this part, I will go so quickly. So when I start with, where is it? Here. Now, row column begins with 0, 1. And because row plus 1 is equal to column, I check these two characters are the same. Actually, no. I put false. I go to line 85, 86, and this move to 1, 2, which is here. Okay, and now again, this is row is equal to column plus 1. So I go to line 75, but unfortunately, B is not A, so this is false. So that's it. And I move row and column to 2, 3, but now 3 is out of the range, so it's the end. So I go to this inner while loop and go to line 88 and increment init column. So now it's 0, 2, the last one. Here's 0, 2. What happens is I go into the while loop. Oh, sorry. Row column should be initiated with 0, 2. And yes, firstly, I can go into the while loop. And I go to line 77. And now we can say A is equal to A. So the first part is true. And dp row plus 1 column minus 1, which is this one, because it's which is true. So I can say this is true. Good. And I go to line 80 and something interesting happens. So C minus row plus 1 is now 2 minus 0 plus 1 is 3. Longest range is tier 1. So current ranks is longer than longest rank. So longest row, longest high is now row column, which is 0, 2. Okay, and I move row and column, so 1, 3, which is out of the loop, out of the range. So I go out of this while loop and go to line 88, and init column is incremented, so now it becomes 0, 3. But now init column is not 2 or smaller in line 68. So I go out of the while loop and I go to line 90, and I return 0.2 string index from 0 to 2, which is ABA. Okay, now I've covered all the lines, so I'm pretty confident in my code. And I passed this test case. Okay, so now I will execute my code. Good, accepted. Accepted, great. Okay, so I could implement this with bottom-up DP. Okay, so now let me quickly wrap up. So today I solved the question, longest palindrome substring. And my task was to find the longest palindromic substring in the given string S and return it. And I implemented three approaches for this. Firstly, 2 pointers, expand from center, which I implemented in my last video. Yeah. And also I implemented this with top-down DP, and also implement this with bottom-up DP. Yeah. So complexity analysis wise, 2 pointers is the best because it takes, all of them takes and square time complexity, but for space complexity, 2 pointers takes only the constant space. So it's the best approach in terms of it. And for approach 2 and approach 3, it takes n squared complexity. And peculiarly, maybe not peculiar, but in read code in Python, bottom-up DP approach was accepted, but top-down DP ended up with memory element exceeded, result. But for the implementation wise, top-down DP is much simple, I think. Okay, that being said, I finished my today's coding practice. Thank you so much. Bye.